a tree-based protocol or a graph-based protocol. So there are some features associated with this graph-based protocol. The thing is that we can use only exclusive locks on a particular data item, right? So the first feature is that whenever a transaction acquires a lock on a data item, it can be only on exclusive mode only. And the second point is that the first lock can be acquired on any data item in a tree, right? So you can acquire first lock on any data item, whereas the subsequent locks are allowed only if the parent is locked, right? So first lock can be on any data item in a tree, whereas the subsequent data items can be locked only if the parent item is being parent node is being locked. And we can unlock a data at any point of time, and each data item can be accessed at most only once, right? So unlocking can happen at any time, and each and every data item can be accessed only at most only once, right? So relocking by the same transaction is not allowed, right? So when a transaction has acquired a exclusive then unlocked it after some time, again relocking transaction is not allowed, right? So these are the properties of graph-based protocols, right? So if you know these six properties, I will be able to work with this graph-based protocol. So the idea is that in graph-based protocol, any transaction can acquire only exclusive mode lock on a particular data item, and the first lock can be done on any data item or any node in the graph, whereas the second lock, the subsequent locks are allowed only if the parent node is being locked, right? So you can lock a particular node only if its parent node is being locked, and you can release the lock, or you can unlock the data point at any point of time, and each and every data point can be locked or accessed at most only once, and relocking by same transaction is not allowed, right? So let us see a simple database graph, right? So you have this graph. A is the root node. So the middle level you have B and C. So they are the internal nodes, and D, E, F, they represents the leaf nodes. So for example, you want to access a transaction wants to access the data items in the node A and F, right? So you all know that the first you can lock any data item in a transaction. So let us assume that when a transaction starts executing, it can lock any data item in the transaction, lock any item in the tree. It's going to lock the data item capital A, right? Whereas it wants to access the data item present in the node F, right? So once it has to access the data item present in the node F, it's not possible to access it, since the parent node has to be locked, right? So only if the parent node E is locked, then only you'll be able to access the data item F. Again, when I have to access the parent node E to be locked, whenever I need to access the data item capital E, then its parent node capital B should be locked, right? So we are going to follow a series of exclusive locks, right? So initially we are going to acquire an exclusive mode lock on data item capital A. Then you are going to access and you are going to get an exclusive mode lock on the data item capital B, and then finally you are going to get an exclusive mode lock on a data item capital E, and then only you'll be able to lock the data item capital F, right? So this is the idea behind tree-based protocol, right? So the first lock can be on any data item, whereas the subsequent locks can be acquired only if the parent node is being locked. So the advantage in this approach is that there is no deadlock. So you all know the deadlock condition in concurrent execution of transactions, right? So more than one transactions will be there. You have a series of transaction. Each transaction is waiting for the data item that is being held by the other transaction, and none of the transactions can proceed, right? So there exists a circular weight of transactions for data items, and none of the transactions can proceed. We say that it's a deadlock. So here the advantage is that uh, this protocol is deadlock free. There is no rollback time. There is no rollback operations being carried out. It has a shorter waiting time compared to other techniques. However, the disadvantage is that the system has to have a prior knowledge of the data access, right? So you need to know what are the data items that is needed by a transaction at the beginning of the transaction, right? So only if you have some prior knowledge of the data items that is being accessed by the transaction, then we can go for this graph-based, tree-based protocol or graph-based protocol, right? Again, the disadvantage is that it leads to unnecessary locks. As in the example, we want to lock only the data item capital A and capital F. So A is locked at the beginning, and whereas since I have to access the data item, I have locked its parent node E. So to lock its parent node E, we have locked the parent node B also, right? So B's parent node is locked. So unnecessarily we are locking two nodes B and E, right? So we have unnecessary locks in this case of graph-based